Right. For some reason today I got a raspy voice, so just bring some extra flair to the video, whatever. We are in your note packets still. However, the next page of your note packet is multiple forces. That is a video that you need to watch tomorrow. It's 15 minutes, 7 seconds long. Okay? That you will watch tomorrow. Fill in that front or that side with those two examples. That will be your homework for the independent learning day. We will check your notes on Wednesday. Okay? So it's probably going to have some point value attached to it on Wednesday. Okay? I remind you also that next week, Thursday, you will have a formative in class on all things vectors. Then we'll start reviewing, and your test is going to be on Wednesday, the 20th. Okay? Also on that 20th day, your salmon packet that you all have received, that will be due. The green formative that you took from 4.8 and the to be determined color yet of next Thursday's formative will also be due that day. Okay? So if you go one more page in your packet, you should be on what is navigation. Yep, it says navigation at the top. Okay? Anybody going anywhere for spring break? Everybody staying and wants up for spring break? Where you going? Costa Rica. Okay, fantastic. I am guessing that you are going to need to fly there because you're not planning on driving or walking there, correct? Okay, all right, that's good. So, if you're in a plane, I'd go back there and I'd do it from you, but my voice, because I'm not very loud today, wouldn't be able to pick up on the video. So let's say that I am your plane. Where are you flying on? Chicago. Okay, so I am your pilot in Chicago. Okay, all right. The door is Costa Rica. Okay, with me? Okay. Works. And you, when it gets to you, and you do the turn around and go, handle it? Okay, right? Okay. Ready? Okay, we take off, and we're flying. And we're flying. Pilots, what is this at Costa Rica? Uh-oh, what happened? One more time. What happened? The wind blew me, right? Okay. And so now I'm not playing at Costa Rica anymore. Now I'm playing somewhere else. That knows where the wind's blowing, right? Okay. So, vectors, we can use vectors to figure that stuff out. And luckily for you, your pilot and the navigation computers automatically just do that stuff. They just adjust it and get you there, okay? Because otherwise, who knows where you're going to go? It really all depends on how strong the wind is blowing, or if there is. Okay? All right? So, we're going to have two forces being affected on the plane. So, the first one is going to be the actual plane. And the pilot is going to set the direction, set the speed, and kick on the cruise control, if you will. Okay? And then that's going to be that one. Then the wind's going to have another effect on it. All of those bearings are back to this one. Where we've got 0, 90, 180, and 270 in that order. Now, we could be given, I don't know, I gotta think of one here now. Okay, so we could be given a bearing of 170 degrees, or like that. Okay? No matter which way it's given, the very first thing that you have to do the very first thing that you got to do is you're going to have to convert your navigation angle into a trig angle. And you're going to have to use that trig angle then for all of your calculations. Okay? Your navigation angle doesn't do you any good for calculating. It just sets your direction. Okay? Then, in the end, you're going to have to give your navigation angle again. So you're going to convert it back into a navigation angle. Okay? Now, the big thing that we're going to use here is vector A plus vector W is going to equal vector G. Vector A is your vessel's vector. If you're on a plane, if you're on a ship, if you're in a car. Okay? It's whatever you're traveling in. That's your vessel. Okay? Vector W is your wind or current, depending on if you're on land or on the water. Vector G is your result, your true ground vector. So what you're actually doing. Okay? If the wind is blowing at me, it's going to slow me down. If the wind is blowing from behind me, it's going to speed me up. Same thing with currents. Okay? If you're fighting the current, you're going to go slower than if you're going with the current. Okay? Do this. Plane has an airspeed of 450 miles an hour on a bearing of 150 degrees. So that is my plane, what it's doing. That's my vessel. That's my A. $150 bearing. Would be down there, which would be a trig angle of that trig angle be? Give another number. Nope. 300. 300. Okay. So my vector A magnitude is speed. So we get that. Agree? Wind has a 60-degree bearing and it's going at 50 miles an hour. So the wind has a trig angle of what? Thirty. Calculate what vector G is then, if G is A plus W. Agree? Yes? Okay. So now that's our vector. We need to find the magnitude of it, because that's going to be the speed. So that's going to be what we got for a speed. Yeah. because they're word problems, we gotta have labels on our answers too. Okay? So that's 452.77 miles per hour. What we got for a direct or a reference angle here? Reference angle. What do you got for a reference angle? Right? Because that's what we do. So whenever we're finding an angle, because then it puts it in reference angles or acute angles. Positive, negative puts me down here, right? Vector G is down there. So my reference angle is there. So my direction is going to be that. Questions, comments, concerns, clarification. That would give me my trig angle. I want my direction angle. So I could, and then convert it to a direction angle. But why not just go right to the direction angle? What do you mean? Well, where's 0 in direction? Where's 0? In direction. Straight up, right? Okay. And then which way do we go? So that means we're going that way, right? So what do you think I added to it? Added 90 to it. Yep. Because here's 0, here's 90, and here's my reference angle. Okay? You want to try one on your own? Yeah? Here, let's do this. Set up your vectors. Don't do any vector calculations, meaning don't calculate the magnitude, don't calculate the direction. Just set it up first, and we'll see your setup. Okay? Set it up, and then we'll see it before you do your calculations. Plane, 300 degrees, 500 miles an hour. That's my A. What's my trig angle? What's my trig angle associated with a bearing of 300? 150. resultant is there. So that's going to be my W or my G. That's going to be my G. What's my trig angle? What do you got? 145. A plus W is G. We need to solve for W, right? So W is going to equal G minus A. What is G minus A? Yes? Now finish the problem. Yes, ma'am.
Okay, so what is it you kind of like at the very top, like find that
Mm-hmm.
of 500
So 150 degrees. Cosine is negative square root of 3 over 2. So 500 divided by 2 is 250. Times negative square root of 3 is negative 250 square root of 3. He was on unit circle. Further questions? All right, try the next one. I will warn you before I even flip the page. There is one very key word that you need to read in the problem. If you miss it, you'll probably be going in the wrong direction. Okay? So again, I ask you, set up your two vectors and wait. Give me a couple of minutes to get those set up, and then I'll show you and then compute afterwards. Because I guarantee you, last class I warned them, they still missed it. Okay? Right? Very key word. Maintain there and there. So that's going to be A, W, or G. That's G. Yep. Bearing of 330. So that's going to be up here. What's my trig angle? What's my trig angle with a bearing of 330? 120. Okay. Wind. That's obviously going to be W. So that's 145 degrees, yes. Okay. But where's it blowing? Key word is from. So which way is the wind actually blowing? Wind is actually blowing that way because it's blowing from that direction. So it's going 180 degrees the other way. So what is the trig angle associated with my wind? 125 degrees. My reference angle here would be 55 degrees, which this one then would be 55 degrees. So my trig angle is 125 degrees. we need to find A, correct? So we're there. So my plane direction for the bearing is going to be okay. Typically, if we give you the original bearings in straight up degrees, that's how we want the answer. If we give you original bearings in the problem in the crazy north-south angle east-west form, that's how we then would want those answers. Okay? You don't have to give both. Okay? Typically, however it's given in the problem, that's how we want it in the answer. Okay? You now can start the next worksheet, which is the vector application worksheet. I again remind you that you have a video to watch tomorrow on Independent Learning Day and take notes on. We will grade those notes on Wednesday.